Previously on CSIS 2470.
So let's head back to the presentation mode, PowerPoint slide, and take a look at our final topic for the day, which is operators. Now you recall there are four types of operators. We have the comparison operators, the logical operators, the assignment operators, and the math operators or the arithmetic operators. And the acronym CLAM, or if you want to use the acronym CALM, whatever works for you, or MALC. Some of you will appreciate that one. Okay, so let's take a look at each one of these here and see what the basic idea is. Let's start with the assignment operators. If you look at that little block of code there on the screen in black over there, there's no number there, but let x equal 10. We say it that way, let x equal 10. But the truth is that symbol is not the equal sign. There isn't an equal sign in code, right? That's not the closest thing we have to that is when we have two equal signs put together. I mean, the symbol on your keyboard is called the equal sign, but in code, it has a different meaning. So when I refer to it as an equal sign, I'm only using that because that's the name of the key on your keyboard, right? So if I put two equal signs together, I get this thing over here. Well, what is that thing over there? That's the comparison operator for seeing if things are equal to each other, right? So it's a little confusing to keep it straight in your head, but get used to that idea. And especially it gets confusing because we literally say, let x equal 10. We say the word equal when we're reading that line, let y equal 5. What's really happening there, if we were to properly say it, we would say, let x be a variable that is assigned the value 10. And let y be a variable that is assigned the value 5, right? If we're using the var keyword, we're saying basically create a variable called x, var is short for variable, and assign it the value 10, and so on. So that's an assignment operator. If you look down at the third little green letter down there, the A for assignment operators, you'll see we have the equal sign. Again, that's just the name of the key, not what it does. Then you'll see we have the plus equal, the minus equal, the multiplication equal, the divide equal, and the percent equal. We'll look at all of what those do in the code in just a minute. And that percent is not percent, I apologize. That's the modulus operator. It is a percent symbol on your keyboard though. So we'll look at all that in the code in just a minute. Let's look at the third line over there that says let sum equal x plus y. Again, this is still an assignment operation. We're saying let sum be a variable, set its value to be whatever x plus y is. So sum has a value of 15. Look at the next one there. Let is equal. Now we're doing a comparison operator and an assignment operator. We're going to let is equal be whatever x triple equal sign y is. Well, what the heck is x triple equal sign y? It's a question. And the question is x equal to y on two levels? Are the values equal and are they the same data type? And the answer is no, right? Yeah, they're the same data type, but they're not equal to each other in value. So x triple equal sign y evaluates to false. So let the variable is equal be equal to false. That's what's going on there. So that's one example of a comparison operator. We'll look at all the other ones in just a minute. Some of them we're going to kind of skip because you should know them from before. They're from grade school, right? For example, the last four here, we're not going to bother. This is just saying is something greater than something, or is something less than something, less than or equal to, greater than or equal to, right? But we will look at these first four. All right, let's look at the next line down here. Let is true be assigned the following. All right, this big parentheses here. We're now doing a comparison with x and the number 7. So we're asking the question, is x equal to 7? The answer is no. But then we have those two pipe symbols. That is the OR operator. That's a logical operator. That's the L of the CLAM or the CALM acronym. So we're saying is x equal to 7 or is y equal to 5? Well, y is equal to 5. That being the case, that whole thing in parentheses evaluates to true because it is the case that x is 7 or y is 5. That is true. So let is true have the value true, which is whatever those parentheses evaluated to. Last one there, let is false have the value x is 7 and y is 5. So what we're using here, we're using 3 of the 4 letters in the acronym. The first one there, right after the word is false, where we have a single equal sign. That's the assignment operator. So that's from the A section. We're assigning the stuff in parentheses to is false. Next up, we have x double equals 7. That's asking the question, is x equal to 7 in value? We don't care about the data type, and we'll look at what that means in code in just a minute. And the answer to that question, by the way, is no, x is not equal to 7. Then we have the logical, right? So that's the L of the acronym. We're using a logical operator, the AND operator. So we're saying, is x equal to 7 and y equal to 5? Well, yeah, y is 5, but it is not the case that y is 7 and y is 5. They both have to be true for that whole thing to evaluate to true. And you'll see my note there in the PowerPoint in the green comment says true on that bottom one. That's actually wrong. That is a typo. So ignore that. That should say false. Maybe I'll fix that magically in post. And I fixed it magically in post. Okay, so hopefully this basic idea here makes some sense. We're going to take a look at a couple of slides that have tables here that will give a little bit of clarity to each one of these so that we don't have to do as much of it in the code. And these are available in the lecture notes. You can just download these and use them anytime you want as a reference. Let's take a look at the first one here. These are the comparison operators, the C from the CLAM acronym or the CALM acronym, right? So on the left in blue, the left column where everything's blue with the white text, that's the operation, and in parentheses, what we're talking about, right? What the operation is doing. And then we have down the middle column there is the code you would write and what the result of that code would evaluate to. So the first one, two equal signs. Well, two equal signs is asking the question, are these equal in value? It doesn't care about the data type. So in our example there, 5 double equal quote 5. Well, quote 5 is a string and the number 5 is an integer, but they both have the same value, 5. So that will evaluate to true. The next one, however, will evaluate to false because it's looking for the value to be the same and the data type to be the same. And that's not the case. We have an int versus a string, even though the values are the same. There's a false. Not equal. 5 not equal to quote 5. Now this is going to be a little bit of a mind warp here, right? It's a little confusing. 5 not equal to quote 5 is false because 5 is equal to quote 5. Hopefully that makes sense. If I were to take that exclamation point out of there and just have 5 double equal 5 in quotes, like we have on the first row up there, then of course that's true. But we're basically saying 5 is not equal to quote 5, which is a lie, right? Because 5 is equal to quote 5. Hopefully that makes sense. Okay, next one. We have 5 not double equal to 5. That is true. Because it is the case that 5 triple equal quote 5 is false. So when we're talking with the exclamation point and two equal signs, it's the counterpart to the three equal signs. So if you look at row 2 there, 5 triple equal quote 5 evaluates to false. So on the fourth line, we're saying that 5 is not equal to the value 5 and the data type, which is a true statement. Okay, the last four should be pretty intuitive. 5 is greater than 3, that's true. 5 is also greater than or equal to 3. Then the next one, 5 is less than 5 is false, but 5 is less than or equal to 5 is true. Take some time to study this because the first four can get confusing, particularly the ones with the exclamation point, the not operator. It's a logical not operator, okay? Next up, we have the logical operators. The first three here, forget about what values you might type, what numbers, what things you're comparing. What we're looking at is if I have an AND operation, what must be the case for it to evaluate to true or false? So we're looking at the first row there, and if I have something that evaluates to true, whatever that something is, and then I have something else that evaluates to false, then the whole thing is false, right? If, on the other hand, I have something that evaluates to true, we're looking at the second row now, and then the thing on the right of the two pipes there is false, then the whole thing is still true because one of them is true. So the first row is saying, I have true and false. Well, that whole thing becomes false. The next one, I'm saying I have true or false. Well, then the whole thing is true. So let's take a silly example here. And I'm going to use some things that maybe you would disagree with being true, but just for the sake of this, we'll go with it. So first line, let's say that the thing on the left that's true is that apples are food, right? I think we all could agree that's true. Then let's say the other thing on the right where it's false, we're saying cars are food. So that whole statement would be saying apples are food and cars are food. Well, that's not true. Look at the next row though. Apples are food or cars are food. Well, yeah, that's true. Part of it's not, but the whole thing is true because we said apples are food or cars are food. Well, that's actually a true statement. Next one, we can say not true is equal to false. That is a true statement, right? If I put that exclamation point before true, I'm reversing its value. So if I have anything that evaluates to true and I put that exclamation point in front of it, I'm now saying that that thing is the opposite of what it was, that it's now false. So if I were to have apples are food and then I put an exclamation point in front of it, I'm now essentially saying apples are not food, right? And so I take anything that's true, put an exclamation point, it becomes false. It's the same thing as the thing in parentheses right below it, where I could say true is not equal to false. Next group there, we got true and true. If two things are true, and I'm saying this one's true and that one's true, the whole thing's true. If the two ors are both false, it evaluates to false. And then if I'm saying something's not true, well, then it's obviously not going to be equal to true, which is why that bottom one evaluates to false. I know these are long and kind of boring, and I promise this is the last lecture that's going to be like this. Most of the time we're going to be coding and having a lot more fun, but we got to make sure that this part is solid in our brains before we move on. Speaking of moving on, if we look at this slide here, we have 4 columns now. Far left is just the listing of the operation. Then we have a line of code in this second spot. Then we have an equivalent thing, which we'll talk about in a minute, that may just help us understand it better. And then the final value of x. We're going to assume that we've declared the variable x somewhere else in our code, let x equal something, and then we've reassigned it to the value 10 right there. So that's the assignment operator, right? X is being set to the value of 10. The equivalent is exactly the same, right? There's nothing special there, but the final value of x is 10, right? Look at row 2 though, x plus equals 5. What we're saying there, look at the equivalent column there for that, x equals x plus 5. That's a valid line of code. And it's the same thing as the one right before it there, x plus equals 5. What we're saying is take x and set it equal to whatever x already is, so 10, and then add 5 to it. And so that's the new value, 15. Right, the next line, I'm just going to go through these quickly now because you should have been exposed to this before. And once you understand one, you should be able to recognize all of them. So we're taking the new value of x, 15, on the third row there. X minus equals 2 is saying take whatever x is, subtract 2 from it, and that's the new value of x, which is 13. X times equals 2, well, it takes 13 and makes it 26. X divide equals 2, so we're dividing 26 by 2, which puts us back at 13. The last one, modulus. So we're saying take 13, which is the value of x at the moment, modulus it, right? What does that mean? It means divide it by 11, in this case 11, and give me the remainder. Well, 13 divided by 11, it goes in one time with a remainder of 2. So we're saying x equals whatever x's value modulus 11, which is 2. So x's final value is 2. Again, print these out from the lecture notes and study them. All right, the final one here, a little bit different looking table. These are the arithmetic operations. I don't think I need to explain any of these. I just told you what modulus does a second ago, and the rest of them should be pretty self-explanatory. So hopefully I don't need to go into any depth on those. All right, let's wrap all this up by looking at an exercise that kind of pulls all of this stuff together. So we're going to code this up in a second, but I wanted to take a look at it first, and I want you to look at it and see if you can figure out what it's going to do. So take a minute to pause the video and think through this. Don't type it into your code editor. Just look at it and see if you can figure out what's happening here. Do the code. Let's clear this out. And let's take a look at this here. Line 1. All we've done is create an array called numbers, and it has 5 values in it. And the index goes 0 through 4, right? 10 is the 0th, 20 is the 1, 30 is the 2, 40 is the 3rd element, and 50 is the 4th element, right? 4th element. Then we have another variable, not an array. We're saying let sum be a variable that's value is 0, right? Well, we have an array of numbers, which makes sense that we gave it the name numbers. We have a variable called sum, which probably tells us we're going to be doing some counting, and we're going to increment sum somewhere along the way. And now we have line 3 where we have a for loop. Now you notice here we're using let I instead of just plain I. Totally fine, right? I go back and forth, right? It's fine to do it that way. So we just have a for loop, which you should be very familiar with at this point. And we're saying I is going to go from 0 to the length of the array, right? numbers.length. We looked at that a little bit earlier. Well, what is the length? The length is 5, right? So it's going to go 0 to 5, but when it hits 5, it won't iterate because it'll be the end of the loop. So that's why we'll get the values 0 through 4. So in the loop, we're going to take sum and we're going to plus equals, right? That's the same thing as saying sum equals sum plus whatever the value is, right? And remember, numbers is our array here, right? That's this array on line 1. And we're going to take the ith element and add it to the sum. And it'll keep a running total of what the sum is, right? So the first time I is 0, which means it's going to take 10 and add it to sum. Second time through the loop, I will be equal to 1, which is that element, and so on down the line till we get a total, right? So this line and this line are the same, right? So I'll comment out 1 and we'll switch back and forth in a minute. We'll leave line 5 for just a minute. Now I have a new variable called average, line 8. And I'm going to say let it equal to the sum, which is going to be 10 plus 20 plus 30 plus 40 plus 50, divided by the number of numbers, right, which is 5. That'll give us our average. And then we're going to console it out. We're going to say, okay, the sum is, let's put a space there, this, right? And then here, we're going to say console.log average is whatever that is. And here we go. Let's run it. Let's see what happens. You can see here, sum is 150, average is 30. Now notice, of course, if I switch these two, sum plus equal, we still get the same. Hopefully that makes sense. All right, the last thing here, I'm not going to go through these questions here, but I want you to take a look at them. If you feel you can answer those 8 questions, then you've learned what I needed you to learn from this lecture. Again, I promise future lectures will be a little bit more exciting than this one was. This one was a lot of dry bullet points and PowerPoints and stuff. Future ones will have a lot more fun building little mini projects and a little bit more code. But look at those questions, make sure you can answer them, and not only will you have learned what you need from this video, but you'll also be ready for the quiz that goes along this lecture. So thanks for attending the lecture, let's call it that, rather than just saying thanks for watching. And I hope this quick refresher, I don't know if it was quick, but I hope that you feel more confident as we go into more advanced topics in the rest of the semester lectures. That's it, folks. We'll see you in the next lecture.